Good morning, students. In the yesterday's video session, we have gone through the law of conservation of total linear momentum and an example of recoiling momentum. And today, you can go through impulse. So, before going through this session, I will ask you one question. Can you be able to catch an egg? Suppose, assume that I am throwing an egg to you. Is it possible for you to catch that egg without breaking the egg? So analyze this thing. Is it possible to catch an egg by your hand without breaking if someone is throwing on you? Actually, it is possible if you are reducing the force on that egg, we can catch that. So average force on that egg, if we are reducing, we can catch that. And this average force we are saying impulse. You can tell in terms of impulse, it is just an average force. But the thing is, the definition for impulse is, assume that a very large force is acting on a system within a short duration of time. That's what I told. When someone is throwing egg on you, you know that it is not possible to catch that egg without breaking it. Actually, you see, when the egg is thrown, it is having some force. And what you are doing means you are trying to stop with that egg within a short interval of time. When you are trying to stop that egg with a very short interval of time, what will happen means very large force is acting on that egg. So that force we are saying impulsive force, or you can tell impulse. So you can take this as an example. So someone is throwing egg on you and you are trying to stop that egg suddenly. It is moving with very fast with a force, and you are trying to stop it very quickly, very suddenly within a short duration of time, so that some force is acting on the object, a very large force is acting on the object, and this force we are saying impulsive force or impulse we can tell. So if we are saying the definition, if a very large force act on a body for a very short duration, then the force is called impulsive force or impulse we are saying. Let us assume the force F act on a body in a very short interval of time delta t. So let F is a force which is acting on a body in a very short interval of time delta t. So from Newton's second law, we can write F is equal to dp by dt. So from this you can write dp is equal to f into dt. So we can integrate this equation. So integrate this equation for initial momentum to final momentum. So this is PI means the initial momentum of the object at a time. I'll show you f dt. Here you can write TA, here you can write TF. And what is this TA means? Initial time TA, this is the final time TF, and this PI means initial moment of the object at the time TA, and PF means the final momentum of the object at the time TF. Now if we are integrating this equation, we will get what we will get integration of dp we know, we will get P. So Pi Pf is equal to F dt, Ti and Tf. This one no need to integrate now. And substitute this limit, upper limit minus lower limit. So upper limit is Pf minus Pi. So Pf minus Pi is equal to, you can write Ti to Tf F dt. And what is this Pf minus Pi? This Pf minus Pi, you know that Pf minus Pa, that is a change in momentum. So change in momentum, this equation shows what? If there is a change in momentum within a time interval Tf minus Ti. So this integral equation f dt Ti to Tf, you can tell that this is called what you can tell impulse. This equation you can tell what impulse, or it is equal to the change in momentum. No, this Pf minus Pi you can write delta P. So this FDT, integral FDT, I am taking as J impulse. So if I am substituting this Pf minus Pi, delta P is equal to integral of F dt Ti to Tf. This is what we said impulse. So impulse J is also what J only symbol we are using for impulse. So impulse is equal to what? The rate of change of momentum. So impulse is equal to the change in momentum of the object. So also you can tell this integral of f dt Ti to Tf. Suppose from this equation, you see I am writing again that equation, delta P is equal to f dt Ti to Tf. So this delta P means the change in momentum, and if you are integrating this T, delta P is equal to f is constant, dt we are integrating. So delta P is equal to what we will get? F into T. So Ti Tf. So delta P is equal to f of Tf minus Ti we will get. And this is what we can tell that impulse what change in momentum, and this impulse is a vector quantity and its unit is what we can write the Newton second. So from this equation we can tell that whenever there is a momentum of the body changes very quickly, so the average force acting on the object is very larger. That's what I said the example for an egg. When you are throwing the egg on a person, if he is trying to catch that, there is a change in momentum which is happening very quickly. So what is happening means the average force produced on the object is very much larger. So this is what about the impulse, and you can tell some example for this, and you can tell this from this equation. You can write what delta P is equal to F into Tf minus T means, so delta P is equal to F into delta T you can write. Tf minus Ti means initial time and final time. So there is a change in time, that is what we can write delta T. So delta P is equal to F delta T we can write. So from this equation I can write F delta T is equal to delta P by delta. So next page I am writing. So F delta T is equal to delta P. From this F is equal to delta P by delta T. So average force you can write this one. So you see there is a change in momentum over time. So there is a large force, average force is producing whenever there is a change in momentum with a very short interval of time. So that this is a equation, and you can write this delta P is equal to what? We know that delta P we can write change in momentum we can write impulse. So F average you can write J by delta T. So J is equal to, you can write F average delta T. This is what impulse equation. So again you can go through that. So from Newton's second law, impulse means what? Impulse means very large force is acting on an object within a short interval of time. That is what. So let us assume a force which is acting on a body within a short interval of time. So that from Newton's second law, F is equal to dP by dt, we can write dP is equal to what? You can cross multiply this. So F into dt we will get and we can integrate this dP with a limit pf to pa. Pa means what? The momentum of the object at the time ta, and pf means the momentum of the object at the time tf. And if you are integrating this time, we can integrate from initial time to final time. Ta means initial time, tf means final time. Now if we are integrating this dP, we know the integration of dP is p. So p is equal to, we can put the limit, upper limit, lower limit. This one no need to integrate because we are going to write this integral f dt is called the impulse. For that we are applying the limit over here. So pf minus pa is equal to f dt with the limit tf ta will come. So what is this pf minus pa means? Pf minus pa we can write delta p. So if you are writing the delta p here, what will happen? Delta p is equal to f into delta t will come, and that delta p means change in momentum, which is equal to the impulse j. So that is what we have written here. I have wrote here. So that delta p is equal to, this is equal to j. That is what. So change in momentum also you can tell it is equal to the impulse. And now you can see, you see delta p is equal to f into dt. Now integrating this dt, integration of dt is t, and timing, initial time, final time. If you are putting this, delta p is equal to, we will get this equation. And this tf minus ta is called the change in time, delta t. So that one I am writing. So delta p is equal to f into delta t. And from this equation, I can find out the force, the average force producing. So the F is equal to dP by dt you can take up. And this delta P means what? Which is called the impulse. J by delta T we can write. So J is equal to F average force over time. So this is what the impulse, and it is one of the very important 3-mark question. So all of you go through this derivation. It is a very important 3-mark question. Now you can write some of the example about this impulse. The first thing is, you know that here you can see the cricket players. You know that he is catching the ball. Here 2 people you can see, both are catching the ball, and this is you keep as person 1 and person 2. Here, when a cricket player catches the ball, why he pull his hand gradually in the direction of the ball motion, and you can explain why. You see, he is trying to catch the ball without moving his hand backward, but this person is trying to catch the ball where the direction of the motion. So this is the direction of the motion of the ball. We know that the ball will move this direction. So in the same direction he is moving his hand. So which person will get hurt more? Person 1 or person 2? This is my question. You can analyze that. I will tell that the person 1 will hurt more, because you see, if you are saying that if it is a ball very small only, but when a batsman hit the ball, it will move with a very large force. That very large force, so there is a change in momentum whenever there is a change in momentum, the force will be larger. So during this large force, this person, he is what of? When this ball is moving, this person suddenly, within a short period of time, he is trying to stop the ball. So there is a change in momentum. So the average force will be larger. So due to this larger force, what will happen? His hand will get hurt. So to avoid hurting the hand, what we have to do while we are catching the cricket ball or football or any ball, we have to move the hand a little backward. Also, the same example we can tell that football players, goalkeeper, always he will catch the ball by moving his hand backward, because what? He has to reduce this impact. Also, that this is a second thing in nowadays in every car you can see that airbag. So actually, what is the use of this airbag? We know that when a car is meeting with an accident, assume that one car is met with an accident. So what is happening means momentum is changing within a very short time. Drastically, this momentum is changing. And we know that during this time it is dangerous for the passenger who is sitting inside. He will experience a larger force. So that what will happen? His head will go and hit the dashboard and he may die. So to avoid from this, what happened means to avoid from this shock, nowadays these cars are designed with a bag. So that what will happen? Whenever this car or something met with an accident, the momentum of this passenger is reducing slowly. So the average force acting on them also will be smaller. So this is what nowadays we can see in every car. So it will be, we know that in every car it is fixed with an airbag. So what is the use of this airbag? It is preventing us from what? Fatal shock, or that sometimes the person may die when he is going and hitting the forward. So this, maybe assume that the car is moving with a speed of some 80 km per hour or 100 km per hour, and when it is met with an accident, what is happening? Because of the change in momentum, there is a large force is producing, and due to this impact, he may hurt. So that now it is designed with an airbag. So this larger force is getting reducing, so that the impact on this person also will be less. And you can see in our motorbike and nowadays in bicycle and all, you can see the shock absorber. This shock absorber in the car as well as in the motorbikes and this what you can tell this bicycle and all, you can see that front back side there will be two shock absorber. Actually, that what the job which is doing the airbag in the car, the same job is doing by this shock absorber in the two-wheelers. That you are going in a two-wheeler motorbike, and you are going very fast. Suddenly you have seen a bump, and what you did with the same force, you are moving. You are not reducing the speed on that bump. You are trying to jump. So what will happen means a sudden force is transferring to the vehicle. So because of that, what will happen? Your backbone will get hurt. So to avoid from hurting the backbone, in the bike they are using the shock absorber. What will happen? It will transfer the force onto the body to the, what will happen? So whatever the force, large force is reducing means the shock absorber is there on the vehicle, means it will absorb this force. Absorb this force means it will reduce the impact which is getting on your backbone. So that is the use of shock absorber. So vehicles without shock absorber, surely it will harm your body. And if you are traveling, if you are passing through a bump, it will hurt on your backbone. And another example is the fourth example is assume that you are jumping from a wall to a concrete cement floor as well as sand cement floor, and you are jumping concrete cement floor, sand floor. So which one will you hurt more? Means once you are jumping on the cement floor, you will get hurt more than the sand, because we know that sand brings our body to rest slowly. But what will happen to the cement floor? Suddenly when we are jumping, it will try to stop within the large force is trying, because when we are jumping with a force. So that force suddenly it is trying to stop. So when it is stopped suddenly, what will happen? Yeah, our body will hurt more. So to avoid from this, if you are jumping in the sand, so what will happen? Yeah, it will make our body to move to rest very slowly, not suddenly. And these are the example. First one is about the cricket player. So catch the ball not like this. You have to move your hand backward so that you will not get hurt. And the use of the airbag in your car. So that one is the shock absorber on your two-wheelers, and jumping on the cement floor than a sand floor. So these all are the best example we can tell for this impulse. And this is what I asked you first. If an egg is thrown, can you catch the egg safely without breaking it? How? You can explain me on your next Zoom class. And thank you all. This is one of the very, very important question. You can go through that. Thank you all. Bye bye.